This is a tutorial on how to solve empirical formula problems. This particular problem has a bunch of numbers given to you in a data table, and first you need to figure out what the masses of those substances are. Okay, so they give you the mass of the weighing dish, which is something that you would always put some kind of substance in. Then they give you mass of magnesium metal in the weighing dish. So this is the total mass of the dish and the magnesium. And they also give you the mass of the dish, the magnesium, and oxygen compound, which is the one that you're going to have to find. The first question asks, what is the mass of the magnesium and oxygen compound? So we go to our data table, and when you look, the very first number, 31 grams, is a total mass of the dish with the magnesium and oxygen compound. So as long as we subtract the mass of the dish, we're going to be able to get the mass of the compound itself. Okay. Then what is the mass of the magnesium in the compound? That's question number 2. So again, let's go back to our data table. What information do we have? Well, we know that the magnesium metal and the dish itself weigh together 23 grams. So we're going to take that number and we're going to subtract the mass of the dish from it. It should give you 12 grams. We are then going to go on to question number 3. What is the mass of the oxygen in the compound? So this one is a little bit more complicated because you have to do a few steps. Well, we know that together the mass of dish with the magnesium and oxygen together weigh 31 grams. Okay, we then can subtract the mass of magnesium and the dish from this total, and that will give us just the oxygen itself. So these two questions just ask you to manipulate the information that's provided to you in a data table. That's 6, 7, and 8 grams. The next question, it's asking you to convert the grams of magnesium from question number 2 and grams of oxygen from question number 3 into moles of magnesium and moles of oxygen. This step is absolutely necessary. You may not use the grams to figure out the formula of that compound. You do need everything in moles. It's kind of like your base unit. So we're going to take the 12 grams of magnesium and we're going to convert it to moles. We have no idea how many moles this is, so we're going to put an X there. What I know from the periodic table is that for every 24 grams of magnesium, there's 1 mole of magnesium. When you cross multiply, you'll be able to figure out that this is in fact 0.5 mole of magnesium. This is the number that you're going to need for your final calculations. How many moles of oxygen are in the compound? You do it the exact same way. So we take the number that we calculated in number 3, and that's 8 grams of oxygen, and we're going to figure out how many moles this is. We know from the periodic table that for every 16 grams of oxygen, there's 1 mole of oxygen. When you cross multiply these numbers, you are going to get 0.5 mole of oxygen. So here are your numbers, and those are the numbers that we're going to use for the final calculations. Unfortunately, I'm not able to see the rest of this screen, so I'm just going to transfer these 2 numbers to a separate document and rewrite them for you. You just go ahead and follow along with the end of the worksheet. So the next step is asking you to write a for every statement involving those 2 moles. So we're going to write down that for every 0.5 moles of magnesium, there are 0.5 moles of oxygen. Um, None of the formulas ever that you will ever see will have decimals as subscripts, so we're going to have to reduce those. Since they're the exact same number, all we have to do is just divide it by the same exact number. And rewrite your for every statement. So for every 1 mole of magnesium, there are 1 mole of oxygen. And now you're ready to rewrite your formula. And since we don't write the ones, we just leave it as MgO, and that's magnesium oxide.